Here we go. And yeah, welcome to episode, what are we on, 91?
Yep.
Of Quarkus Insights. This time we have Martin, who's going to talk about non-standard non-standard features of CDI, I guess is what we call it.
Yeah.
And I don't have that much news today. I'll just remind people about JNation that's happening in 2 weeks, where a bunch of people from Quarkus will be for there's a Quarkus event day and a Quarkus unconference, I think it's good, which is 2 weeks. So JNation is a place to go. I unfortunately can't be there because I'm moving that exact day on all days. So yeah. So anyway, well, let's jump into it, Martin. Do you want to go on and start the screen?
Yeah, for sure. So, hi everyone, I'm happy to be here again. This time we should talk about CDI non-standard features, but I think that we can talk about CDI usage in Quarkus in general. So if you have any questions, just feel free to ask during the presentation.
Yeah.
So I have some slides prepared.
Yeah, we don't like slides, but it's okay.
Yeah, but today I don't have that many, or maybe even I don't have any live coding because it's mostly about small snippets of code.
Yeah.
So I don't have any examples, just a few slides. Can you see my slides now?
Yes, they are on screen now.
Perfect. Okay, so this is CDI and ARC. We should talk about these two today. CDI on the left is a standard. It's originally created as a specification under the JCP process, so it was part of Java E, but now it moved under the Eclipse Foundation, so it's now part of the Jakarta E. So we'll talk about the progress later. And on the other hand, we have ARC, which is our Quarkus dependency injection solution, which is based on CDI. So we use the CDI API. Currently, we use the let's say the old version of the CDI API using the Javax package, but we'll talk about the switch to the next package as well. And yeah, so we should talk about these two. Before we start, if you look at on the left, this guy with it's a small dwarf, I think. There was an official logo of CDI of the CDI spec before the move under the Jakarta. So I will use it when I will talk about the standard. And on the right, of course, there is the logo of Quarkus. And yeah, maybe one thing, I often get a question, why ARC? Because it sounds a little bit odd, especially when we talk about dependency injection. So these slides, by the way, are, maybe Max, you can share the slides. There is a link on the GitHub issue. So if you look at this link, you will see a Wikipedia entry, and it basically explains why ARC, because it's a type of welding. And for those who know something about CDI, it's a specification, and the reference implementation was called weld. So that's why we have ARC, because of arc welding. And yeah, maybe the first question, if we talk about components and programming model, might be why CDI? Why did we choose CDI? And why did we decide to use the API but not leverage the existing implementation? So for A, we believe it's a great programming model. That's the first reason. So we wanted to reuse it, similarly as we do, for example, Hibernate or Rest Easy in Quarkus. And for B, Red Hat has been involved in CDI development for many, many years. So we actually led the specification before, and we also implemented the reference implementation, and we also implemented the TCK, which is a set of tests for the implementations, so that they can prove that they they comply with the spec. So these are the main reasons why CDI was chosen. And another question might be, okay, but why didn't you just take Weld, the existing reference implementation, and use it in Quarkus? And the reason is that we try to switch to the next slide. Weld simply did not met our goals and our design goals, let's say, of Quarkus. So Quarkus is a build-time oriented stack. So we try to come with something which is build-time dependency injection. So I call it, this is the first slide of comparing the CDI standard and what we have in Quarkus. And the number one, the biggest difference is that our DI solution is a build-time oriented dependency injection, which is not the case in case of the CDI full specification, which is like the usual runtime stuff. So simply put, we wanted your injection points, your beans, your dependencies to be validated at build time, so that your application, if there is something wrong, we want to fail fast when you build your application, compared to the standard behavior where your application fails at startup. So this is the main difference. And it also means that we cannot support all the CDI APIs. I'm talking about the standard APIs, because, for example, the portable extensions from CDI are inherently runtime constructs. So we just cannot support everything. So it's basically a trade-off.
Well, just to be clear, like majority of the CDI spec is supportable, right? It's the edge cases that are
sure. Yeah, exactly. Well, it's edge cases and also the extension mechanism used in the CDI flow.
Yeah.
And it's also, we started with a set of features that we wanted to support, and we are extending the set because, for example, from the beginning, we did not support CDI decorators, but we do support them now because it's mostly about resources and so on. So when we had time, we implemented.
Yeah, and I think that's an important point of saying that with Quarkus, we covered all the features from the early days that we knew was important, like critical.
Yeah.
And everything else we said we'd rather go out with a few missing features and we can fix them over time. But one of those issues we fixed or improved was decorators. But the one that we just can't because it's inherently runtime is the extensions.
Yeah, we also leveraged our experience, let's say, because, like I said, Red Hat is involved in the development of the reference implementation for many years. So we fixed many bugs, and we have seen many use cases and many problems users run into when using standard CDI. So we basically said that we're going to implement the core, which is very useful and commonly used. But then there are probably some features that we don't support yet because they are not that important or are problematic in terms of implementation and so on. So it's important to say that we don't pass the CDI TCK, the original one, because, of course, it was intentionally, because we would never pass the TCK when we don't implement some of the features, right? So we have our own test suite, let's say. And an important thing is that recently a new version of CDI was released. It's called CDI 4.0. There was also CDI 3.0, but there were no changes in features or API. That was mostly about renaming the artifact coordinates. And
like Jakarta 9, right?
Yeah, exactly. But in this, this is really a new version, like some features are added and so on. And one of the most important feature that was added is called build compatible extensions, which is something that is basically inspired by Arc, but it's a different API, and also it targets different how to say that different extension authors. Because in Arc we have all the extension points we have in Arc are focused on Quarkus and Quarkus APIs, and in CDI build compatible extensions are kind of a standalone extensions that these don't care about Quarkus internals at all.
I guess these are like, well, I'll say first, I was surprised in the beginning that there were not that many objections. Also, not objections. That it wasn't like we were missing features, but there were a few, I guess, Apache Delta Spike features that was done as CDI extensions.
Yes.
And those are ones we can't do. But do we know? Are they all possible to do now with the build compatible extensions in 4?
Well, I think that most of the functionality provided by Delta Spike is now taken over by microprofile. So, for example, config and so other specs from microprofile, and these are implemented in Quarkus. I'm not sure whether there are some parts which are not implementable with build compatible extensions. Not sure. But the good thing is that, by the way, two of my awesome colleagues worked on these build compatible extensions, Ladislav and Matej. And the good thing is that the build compatible extensions should work in both, in the build time platforms or stacks, and also in the CDI full platforms. That means that you can now develop one extension that should work in Quarkus soon, not yet, but it should also work in application servers such as Wildfire and so on. So that's a good thing. Yep. I don't know, maybe I had some other thing about CDI4. Yeah, our plan. Basically, what we are planning to do with CDI4. So I hope that we will support CDI4 in Quarkus soon. So that means that those build compatible extensions will work in Quarkus. On the other hand, what we have now is our extensions, Arc extensions API. This should work, and we encourage Quarkus extension authors to continue using our APIs. So only if you are an extension author that is going to develop something for CDI only, not Quarkus specific, then you should go forward and use build compatible extensions. And we also plan to pass the DCK for CDI 4.0, but only the lighter version, just a subset, which is basically, it doesn't contain the portable extensions, which we don't support, plus few minor features.
Cool.
Okay, so if there are no questions about this.
There's none for now.
Okay.
But, the stream is a little bit behind, so it might come later. We'll see.
Okay, no problem. So now I prepared a bunch of small improvements or small features we have in Arc, which are basically extending the existing functionality of CDI. And it's, like I said, these are small features. It's more like a nice to have. It's not nothing really, how to say that, crucial, but it's something that CDI developers can appreciate. Okay, so the first thing we have here is something we call qualified injected fields. So what is it about? It's a very simple thing. We want you to type less when you write your applications. So this is how an injection point in CDI looks like when you use fields. And we can see that you need to use the @inject annotation, and then there are optional qualifiers. Qualifiers are special annotations that allow you to basically enhance the type safe resolution in a way that not only types are considered. So in this case, because we are injecting a string, we need some kind of qualifier, because otherwise there can be many beans that would satisfy the string type, which is coming from Java. And in this case, it's a microprofile config, by the way. And this is how it looks in normal CDI and full CDI. And what we allow you to do is this. Very simple. Just skip the @inject annotation, because if you use a field that also has a qualifier, we know that it's very likely, almost 100%, it's an injection point. So we just say, okay, use the qualifier, and you don't need to use @inject. So if you inject something that has a qualifier, I mean CDI qualifier, then you can just skip the @inject annotation and type less.
Oh, save five characters. That's good.
Well, it's of course. But if you have like 10 injection points in your class, you will save 10 times @inject annotation. And it's also like more clear sometimes. So why not? Of course, you don't have to use this feature. It's just an optional thing. So you can just use @inject @config property if you are used to it. That's your choice. Another thing we try to solve or simplify is constructor injection, which is, by the way, one of the best way how to inject dependencies in your beam, because you can make your fields final and so on. It's also good for testing, unlike the field injections. But the problem is that in CDI and CDI full, if you have a beam like this, which is application scope, which is by definition a normal scope in CDI, then your class must define or declare no args constructor. Always, it's needed because of some technical restrictions. And the other thing is that again, constructor injection, constructor that is injected must be annotated with @inject. So what we do in Quarkus is that, not always, but most of the time, we are able to add the no args constructor for you. You simply modify the bytecode. And also, if there is only one constructor in your beam, we consider it @inject automatically. So it looks like this in Quarkus. This would fail in normal CDI because of the constructor, no args constructor is missing, and also @inject is not there.
I wasn't sure, because when I came back, I remember doing this, and I'm like, shouldn't I have it as constructor? It's like, okay, maybe it's fixed. Okay, so that's arg.
Yes.
And it's not in the spec, because in the spec they don't want to require you to modify the bytecode, I guess.
The spec requires the constructor, so it's really normally there is a test in the TCK that says that your application should fail if you have a class like this, and it would be validated when your application starts. But
so they don't not only require, they also like, it's not just, hey, you support, if there's a default constructor, this will work, but they also want it to fail.
Yeah, CDI itself is very strict and has a lot of, it's called definition errors and deployment problems or deployment errors. So there's a large list of errors you can have when your application starts.
Okay.
Do
we have like a strict mode to run in so we can pass the TCK, or is that?
No, we don't have anything. We do where it makes sense. Then we also fail, but in our case, it's not failing the start of your application, but we fail the build. So a typical example, like I said, is that we are built-in dependency injection. If you try to inject something that is not there in your application, then we fail the build. Unlike CDI full, where you would build the application, build your application archive, then deploy it somewhere, and when the application starts, you would get an error.
Got it.
Okay, next one, unused bins. This one is quite interesting because when we started to work on Arc, we found out that there are, especially when you add a lot of extensions in your application and a lot of libraries and so on, it seems that there are like many beans that are actually never used. But we still need to keep them in memory. We need to keep the metadata, not only the classes, because this is how a CDI works. You need to scan all the beans and know what metadata you need to use in order to, for example, instantiate the bean, what scope it lives in, and so on. And we decided to try something which is, I often call it framework level dead code elimination, because it's very similar to what, for example, GraalVM or native image does when creating a native image from a Quarkus application, where they try to find the classes which are not used anywhere. And then they just simply remove it from the application. So in this case, it's more like we're ignoring beans that are not used anywhere, so that we minimize the number of generated classes and so on. And this should also help to minimize not only the startup time, but also hot reloads when you are in the dev mode, and also memory consumption. One of the problems we had is that CDI has I would call it infamous method. It's a possibility to use a static method for programmatic lookup. It's called CDI current, and many users probably use it and like it and so on. But the problem is that if you look up a bean like this, then it's very hard to detect these cases. And for us, it's hard to detect the unused beans. So it can happen that sometimes there is a false positive in a way that we consider a bean unused, we ignore it, but then you try to look up it at runtime. So first of all, if this happens, we log a really big warning, like we know that you're looking for something, but we remove it. And furthermore, we also allow users and extension authors to eliminate these false positives in a way that you can, for example, add an unremovable annotation to your bean, which means that we simply never ever remove this bean from your application.
This one actually I find interesting because when I read it, I did a presentation a week or two ago about like why, like we break some assumptions to people. Like for example, here every bean will be available, but it won't, because if you haven't referred to it anywhere during build time, we assume it's not needed. And and I was like, okay, how many? Why do we do this? Well, and this is what we said, like that we know the more classes we have in the jar, the longer it will take to start up.
Yep.
And I was like, okay, is it like 2 or 3 classes? But then I look up, if you just start a normal Quarkus app with the REST EC.
Yeah, Max, I'll just sorry to interrupt you, but you're saying something I wanted to show right now.
Okay, I'll shut up then.
No, it's okay. But I only have one demo today, so.
That's one demo. Okay, I'll stop saying it.
Yeah, I just wanted to show what happens if you run the getting started reactive app in the dev mode, which is I have it prepared here. So I will run the application, and if you are curious about how many beans are removed and so on, then we have something for you in the dev UI. So I will just take a look at the dev UI. Hopefully you can see my screen now, dev UI. And here we have some information about Arc. So it's not only the beans that are used in your application, but we also have and some information about the removed components, so that you can see.
What's the number it says? I can't. 66 or something. Yeah.
It's 66 because we have quite a lot of beans from the microprofile config implementation, which has a lot of beans. And yeah, it's 66 beans, and you can take a look at what beans are these, where do they come from, and so on. And we don't like, of course, this is just a number about the removed components. But if we speak about generating metadata, that means that for every class or for every component, being in this case, it might be one to several classes generated. Because in Quarkus, what we do is that during the build time, we analyze your beans, and if they are used at runtime, we need to generate some metadata so that we know in which scope they live and how to create them, how to intercept them, and so on.
Yeah.
And that means that in this case, if we have like 66, beans, that could mean 200 beans. I mean, 200 classes generated. It's not only about beans. So we don't need to generate like 200 classes, and this will of course speed up the build time and so on.
And that's the thing that people don't realize. I did in the beginning. Like, okay, so this actually implies. Well, the reason is one is this is just us starting up. As I said, this is for every property. I think there is a component, and if you don't refer to them, you never need it. And if we just followed the rules, so to speak, we would have to be required to carry these around, and there'll be zero. Like, it's only there for compliance, not for actual reason.
Exactly. And the other thing is that if you build a native image from your application, then if we don't remove those beans, then also the classes wouldn't be removed, right? So it's not only about the metadata classes, but if you build a native image from your application, then the CDI container would hold the references to your classes as well. So it could be a large tree of classes that wouldn't be removed.
Yeah, and this is like you said, this is the basic example. Like there's nothing else. But if you start adding 2 or 3 extensions that might do some interesting things and provide, hey, if you ask for this, you'll have a bean, which is good. But here we reduce it, and it's these small, like if this was not here, it's like dying by 1,000 cuts, right? Like small cuts.
Yeah, exactly.
Because by using the type system and stuff, we can eliminate a whole class of problems, and it makes runtime faster, native compile faster, the binary image smaller, and hot reload is faster. So it's
and it's also more convenient for extension authors, because when we say we remove them automatically, they don't need to care about this, so they can just
they can be more sloppy.
register several beans and they don't care. But if there wasn't this feature enabled, they would have to somehow analyze the application themselves, or just what I mean.
It's good. It's a what's it called? Yeah, it's the quality of a closed world. Like just calculate the closed world and then just remove everything. That's good.
And by the way, if there's someone who doesn't like this feature, most of the features we have in Arc are easily, you can easily disable them. So even this feature can be disabled, so that you can compare your application before and after the change. You can simply say, using a configuration option, that this configuration option is, of course, build time config property. And you can just disable this feature, saying, I don't want to remove anything. That should work as well.
Cool.
Okay. So another one. This is a nice thing. Georgios is not here, but I think he was the one who proposed to create this feature. It's basically a set of annotations that allow you to conditionally enable a bean when either a Quarkus build profile is active or inactive, or when a build time property is specified using a specific value, or on the other hand, not a specific value. So it can be really useful if you want to create, let's say, beans that should be only used in the tests or in the development mode. So you can simply annotate your bean with at if build profile. We have other annotations that are really straightforward. One is unused build profile, and the others are if build property and unused build property, and it works as a filter. So it basically, if you build your application, we take a look at the profile or properties, config properties, and then some beans are just again ignored.
Cool.
This one is also nice, but it's.
I saw there's just someone who, Yuan has said, could you specify a symbol bean with a configuration option? I guess that's for. Could you specify a symbol bean? Do you understand his question?
I need to take a look at it.
He just says, could you specify a symbol bean with a configuration option? Yes.
I don't know what it means. For the unremovable.
Oh, for unremovable, yeah.
I still don't understand.
Basically, he's saying, can you... Yeah, he says, like, can I make a single class unremovable? So you can add the unremovable on the class, but is there an option for it too, like a property?
Yeah. So you can either use the annotation, which can be used for the class, for produce a method or field, because beans are also defined using fields and methods. And then you can also use this configuration property called Quarkus arg on the removable types. And this is basically a set of names. So I think that we support some wildcards too. So we can say, for example, anything that is declared in a package foo should be unremovable.
Cool.
It's definitely described in the docs.
Yeah. So the answer to Yuan is yes. You have all the
yeah. Okay. So we were talking about default beans. This is more useful for extension authors, and I sometimes have trouble or struggle to explain this feature, but it's for anyone who ever used the CDI alternatives. This is very similar, but it's defined the other way around. Because in CDI, you can say that you have multiple beans that satisfy a given a given type, for example, interface foo. And then you can say that some bean implements foo, but it's an alternative, which means that it takes precedence, right? So this is how the standard feature works. But we also found many times that it's useful to be able to say that you define a default bean, and if a user comes with his own bean that satisfies the same type, you just want to ignore the default bean. It's like having a default value. If the default value is only used if there is no other bean that matches the given type and a qualifier. Again, I'm not going to show an example. It's described in the docs, and as I said, it's more for extension authors.
Sure.
This one is kind of interesting. It was, I have to admit that for me, it was more like a challenge. I was wondering, because in standard CDI, because of some technical limitations, you cannot intercept a static method. There's no way. It's not supported by the interceptor spec and so on. So it's clear that you cannot use an interceptor on a static method in Java. And I was wondering if it would be possible to implement this in Quarkus, because we can do anything, right? We can rewrite the bytecode and so on. So we found a solution, and it works really well. So if you have ever need to intercept a static method, which is not private, then you can use it in Quarkus. Just add an interceptor binding to a static method, and everything should work as usual. So this is yeah. Go ahead.
Okay, so that basically means if you add that interceptor on a static method, we bytecode generate that code in that.
Well, it's not that simple, but we do some magic and it works. Yeah, we basically we do some bytecode transformation and some additional stuff, and it works. We should so that we don't want to break your applications, so only the method level bindings are considered, because otherwise suddenly your static methods will be intercepted. That's not something normal users expect. So only method level bindings are considered, and it has to be a non-private static method. And it works really nice. So if you haven't ever need to intercept your static methods, try it.
Cool.
Okay, this one is quite interesting because from our experience, many users write application scope beans, right? This is the very common scope in CDI. But the problem is that these beans are actually shared across your application. So it might happen easily that such a bean is accessed concurrently, which means that in theory, you should make the bean thread safe, if it's not stateless, of course, which is like, yeah, everybody should do it. But in reality, many users forget about this, and sometimes happen that they have some race conditions or unexpected behavior because they don't synchronize or use volatile fields and so on. So
do you have an example of this?
I don't have an example, but
Okay.
Simply put, if you have an application scope bean that has a, let's say, state in a form of a hash map, and then if you have a method that writes to this hash map and reads from this hash map, if you don't synchronize, then you can be in trouble because it's not thread safe, right? So you can see completely different results from different threads. So what we have here is a simple annotation that you put in your bean or method of a bean. And then we associate a special interceptor with your bean, and we use a standard read-write block from Java concurrent package, and protect every method of your bean automatically. So this is nice to have. Like I said, many users just don't care about this problem, but sometimes it might lead to surprising results.
Okay. So this is basically a modern version of synchronized.
Well, I don't think it's a modern version, because I do remember that EJBs had something similar. I believe that it was EJB singletons. They had similar annotation for container managed concurrence. So it's nothing special, like nothing new, but it's useful.
Good.
Okay, this is another one.
Also, wait. So the question like saying, what's the difference with synchronized? So, well, synchronized is done at the JVM level, kind of thing.
Yeah.
But here we're doing container management, and we're using the more. This is why I call it modern. We're using the concurrent package that's in the JDK since.
Yeah. In this case. This read-write block, first of all, it could be optimized for reading and writing. So if you have a method that only reads the data, you can say that you use a lock for reading, which is much more performant compared to synchronized. And also synchronized itself is not enough very often. So you need to add another language constructs.
Yeah, synchronized is literally just a giant Boolean. Like everything gets synchronized, basically. That's what the word means. Right? Where here you can have one method writing and then 1,000 reading. And the reading one will be able to read. When synchronized, it'll be, nope, only one at a time.
Yeah, exactly.
That's the win.
Also, if you are curious about how it works, the interceptor is really simple. So you can just take a look at the Quarkus source code, and you will find a simple class with few lines, so you can even find a bug there. Okay, this one is another feature that comes from practical experience, because in CDI we saw many users that used programmatic lookup to get a dependent bean. And the problem is that although it's well defined in the spec, this could lead or result in a memory leak. Because if you look instance from the CDI API to obtain a dependent bean, then you need to be careful, because every get invocation results in a new instance that is kept there. I mean, it is kept in the context of the bean that injects this instance. So in this case, we have an application scope bean. We inject instance service, which means we are doing programmatic lookup. And if service is dependent, then every service get creates a new bean, and we need to destroy it, because otherwise that dependent bean would be there forever. So if you call ping like million times, then you will very soon see out of memory exception or something like that. So although it's well defined and users must destroy the dependent beans after they are used, very often people forget, which is kind of natural, right? And suddenly a memory leak exists. So what we do in Quarkus is that we have another annotation which is called with caching, and this annotation basically means that when you obtain a bean via instance, then the result is cached and used every time you call the get method again. So simply put, when you first use services get, we store the result in a cache, and then the next invocation of get returns the same instance. So this should mitigate the memory leak.
But doesn't that change the semantic of dependent?
It does.
Okay.
But we believe that it's better to prevent memory leaks than
Sure.
comply with some rules. It's like I said, it's more like a practical observation. We saw it many times. We inspected many heap dumps, and the result was always the same. Like you have a dependent bean obtained via programmatic lookup in an application scope bean, so it lives there forever, and you have like millions of instances somewhere there. So one can argue that it's something that is not well defined or well specified, but it's always a tricky thing. Like it's really hard to define something so that it works in 100% of cases. So I believe it's well defined, it's well described in the spec, but unfortunately, users often don't get it.
Yeah.
Okay. This one. So there's one problem with build time approach. The problem is that when you build your application, the set of available beans is set in stone. So when you run your application, there is nothing we can do about it. We cannot disable any bean, we cannot add any bean, and so on. Like I said, it's a trade-off. So we provide something which is called, I don't know, it's basically a wrong name for it, but we allow you to do some declarative tuning of programmatic lookup, which is not available in standard CDI, which is this slide. So in this slide, we have an interface of service. Then we have two beans that implement this interface. So these services foo and bar, both are available at runtime. And now if you want to use these services, you cannot simply @inject service. That would result in an ambiguous dependency, which makes sense because we have foo and bar, and both of them satisfy @inject service injection point. So what users usually do is that they use programmatic lookup again. So it's the instance @inject instance service, and they can leverage the fact that instance is actually iterable. So they can iterate over all the beans that implement the service interface. But the problem is that it's very hard to filter out those beans or work with them in a convenient way. So in this case, we want to use bar service if a config property, which is called bar enabled, is set to true. So how do we do this in CDI full? We need to inject the config property. Then we need to use the config property and iterate over all the services, do some dirty instance of checking, and then use the service. Actually, I can see I have an error there. It should be service get to do something. Sorry about that. Okay, so this is how it looks like if you use CDI standard to choose an implementation of your bean at runtime. And what we have in Quarkus is that we have special annotations. One is called lookup if property, and the other one is lookup unless property. And it basically means that, and again, I have a problem there. It should be service get do something and not service do something. So how does it work? It actually works that the filtering is performed automatically. So if you do programmatic lookup, here it's @inject instance service. We take a look at the annotations declared on the beans and check the bar enabled config property automatically. If it is set to true, then we use bar. If it is not set to true, then we use full.
Okay. Yeah, and if you for some reason add another service, it will just fail the build, right?
Yes, it will fail because of, again, ambiguous dependency. Yeah, ambiguous dependency.
Yeah. All right. Nice.
Okay, so this feature will also added just to improve our situation in the context that some users wanted to be able to somehow filter or modify the set of beans available at runtime. So it's not probably not what they are looking for, but at least something. Like we can filter or tune the programmatic lookup for them. Okay, this one is my favorite. In CDI, like we had the example before, you can have multiple beans that satisfy a given injection point. Injection point or type. In this case, it's service, but you need to use the special interface called instance. So you need to do something like @inject instance service, and instance is iterable, so that you can do some iteration and so on. We believe that it's not very intuitive. So in Quarkus, what we have is that you can say something like this. Well, list is the interface from Java util. So you can just say inject all list service, and you get an immutable list that is prefilled with bean instances. It looks like a very small change or small improvement, but if you look at this instance, then again, if you iterate over the instance, then every next invocation upon the iterator obtains a new bean instance. So you can run into the same problems like we had with dependent beans, like the memory one. So this cannot happen here because the list is prefilled with one instance, and you can just iterate how many times you want to, and only one dependent bean would be used. You can also check the number of services available, which is not the case in this usage, because there you need to collect all the instances first somehow and so on. So it's just another tiny thing we provide for you. And this is actually the last one on my list, and it's a very special one. I don't know whether it actually makes sense to talk about it, but it's another way how we extend the functionality of CDI standard. Because in CDI standard, you can have something called synchronous observer methods, which basically means that if you fire an event, then you can define async observers that are notified asynchronously. But the problem is that if any of the observer methods fails, then only the emitter of the message, or the class that fires the event, receives the error in a way that it receives a completion stage and can somehow check whether it failed and so on. And there was a requirement that many people, not many, just a few, to be honest, wanted to implement some custom logic when a failure occurs. So this is another way. In Arc, we have a special interface for this, and you can just implement your custom logic for synchronous observer methods when an exception or error occurs. I don't have an example, but we have it in our docs. And that's probably it.
Go back to that one again, the one you had before.
Oh, sorry. Just I'm too fast. Okay. One before there was.
Yeah, just I'll turn you on you again.
This one, you mean?
No, the last one. Exception thrown by async. It's just a handler, so I can actually get those. Okay, got it.
You basically implement an interface and you get an exception and so on, and you can consume the exception, I don't know, do some logging, inject the other bean, and execute some logic and so on. Because by default, the specification says that it's an error and implementations can possibly log an error. That's all that can happen, right?
Yeah. And I saw some Kevin. I think that was I missed his question, but I think that was for the lookup. Says for meta lookup in CDI, I should use a qualifier. No, that was the what was that? That was a few back, I think. Number 9.
Qualifier programmatic lookup in CDI should no. You don't need to use a qualifier for programmatic lookup. Programmatic lookup works in a way that you inject instance, which is a special interface from CDI, and any qualifier you add to this injection point is used during type-safe resolution. But if you don't use qualifiers for your beans, then you don't need to use qualifiers there at all. You can just do @inject full, and if there is a full, which is a default qualifier, which means no qualifier by default, then it should be satisfied. So no, it's not required.
Cool. All right. Anything else in the last 5 minutes?
That's all from me. Maybe if we have a question. No.
Let's see if they pop up. You have a few minutes. So basically, what I hear said is, we do Arc because we wanted to avoid all the extra classes overhead that the dynamic a runtime CDI dependency injection works, and for that we get to have not less features. Like there will be features in CDI that we can't do, especially extensions. But CDI 4, there's going to be a spec that defines how you do build time stuff. And then a lot of the stuff should be all good.
We should also mention that in CDI 4, actually the core of the spec was split into CDI Lite, which is something we cover, speaking of features, and CDI Full. So our plan is to implement the build time. Build compatible extensions. It's too many names.
Yeah.
And to pass the TCK for CDI Lite. That's our plan. By the way, we do implement more features than those that are contained in CDI Lite. It's just a
the one you showed here was a good list of things that we do.
Yeah, but also, I mean, also some of the CDI spec features. They are not included in CDI Lite, but we implement them because we believe that they are useful. So why not?
And Kevin says injective list is interesting. Is that coming for CDI 4?
I don't think so, because the main or the biggest feature that consumed like most of the time was to build compatible extensions, and then just a few minor improvements. And I don't think that something like this got it into the CDI 4.
Maybe in CDI 5. We'll see.
Maybe. Why not? We should say that CDI is, by the way, it's not a dead specification. It's really like the community attempts to add new features and innovate, so we can expect CDI 5. Maybe
you
next
saying
year.
we can or cannot? Or
sorry?
Did you say that we? Are you gonna say that the community is?
It's not dead.
Okay, it's alive. Right?
It is alive. It is not dead, and we can expect a new version. I don't know, maybe next year. I don't know how. It's been quite difficult, because the Jakarta rename and all this stuff. It was quite resource consuming, but it was like infrastructure, like work, and not features and stuff like that.
No. We actually got one here that says, and I think we actually have something here. So, he asked, do we have anything that can help us monitor CDI, like hot, cold methods, slow indications?
Yeah. So in the dev UI, we actually have something. I don't know. Yeah, we call it, but I don't know whether it's actually used that often. It's called invocation trees. Let me share. Yeah, I share it.
Yeah.
And it basically works in a way that we add an interceptor to any bean used in your application. But I need to first invoke some endpoint, right? So what is it? Get a hello. Hello.
Yeah.
Cool. So I should see something here. Okay, right. So we try to monitor the beans, and it should work in a way that you should see the whole invocation tree in a way that if reactive greeting resolves calls a method, we can actually take a look at the source greeting. If we call this method, which is using another bean, we should actually see the tree. So if I use, instead of hello, if I use, what is it? Greeting max? Is it? No. How is it?
It's hello greeting.
Hello greeting. Yeah, hello max. Now if I refresh it, I can see that greeting actually calls reactive greeting service, and you should see the times and so on.
Yeah.
But it's only for the development mode.
Yeah, it's only for development mode, but that should give it. If you want to have like full runtime stuff, you want to use let's say a full profile or something.
Of course. This is just, and also it might run into troubles when you combine imperative and reactive stacks, because things get a little bit more difficult there, so that the contexts are propagated somehow and so on. So if you mix like a reactive stack together with imperative, then you can see sometimes incomplete results. Let's see here.
Yeah. Cool. Good question. Okay. Well, we are on the top of the hour, and I have another meeting to be at. Good. Okay. Well, thank you. And I think actually, let me just check. We have something for next week. I did my calendar. I think it dropped out my calendar. I can't see it, but we have something for next week. That's I think the oh, that's the news actually. We have a I can't. Can you pronounce the new extension? So Andy Damon did a Quarkus quinoa. Just cannot. My quinoa, yeah, which is this extension to enable front end development using NPM or Yarn, that kind of thing. But we are having to manage two different setups, integrate with dev mode and all stuff. So I think that's the next week on Monday. I won't be there, but someone else will be. So yeah, that will be next week. All right, guys. Thank you, and thank you, Martin, and see you next time.
So.